Okay, now let's look at the infinite series. So in the formula sheet at the back, you'll see s to the infinity equals a over 1 minus r. This formula here, you aren't going to use unless they ask you for the sum to infinity. And with this formula, you'll see this thing here. It says -1 r and 1. And you'll see this next to the formula. We'll see what that means. Let's say that we started to sum these numbers to infinity. 3 plus 9 plus 27 plus 81 is 120. The next term is 243. So if we added 243 to this, we would get 363. And then the sum after that is 829. And so if you sum them up all the way to infinity, you'd actually just get an infinitely large number. So the sum of this to infinity, we wouldn't use this formula for. And so the sum to infinity of this one tends towards infinity. So we don't use it for these type of sequences. So let's look at a different... well, let's look at why that didn't work. So this thing here says that r is a number that's between -1 and 1, which means it's basically a fraction that's less than 1 or bigger than -1. For example, it could be -3/4, it could be 2/4, it could be 1/3, it could be any fraction where the bottom is a number that's bigger than the top, or should the absolute value is bigger than the top. So for your SATs, absolute value means just the number without the negative. So the absolute value of -4 is just 4. So that's what I mean when I said absolute value. I don't think you really need to know that for Matric though, but it's just handy to know for when you do maths at university. So let's clear all these and let's try a sequence that would work with our infinite series. Okay, so let's say it's going 4, 2, 1. Okay, so what's happening is this is going downwards. So we see the numbers actually getting smaller and smaller. And so when we calculate our ratio, which is T2 over T1, we see it's 2/4 and T3 over T2 is equal to 1/2. And we see that these are both a half. So they could say, what is the infinite sum of this series? And that's when we would use this formula here. And it's a really simple one. All you do is put in A, which is the first term, 1 minus, and the sum, which is a half. Sorry, the ratio, which is a half. And so we get 4 over 1 minus a half is a half. 4 divided by a half is the same as saying 4 times 2, which is 8. We look at these ones here, and they equal to 7. This half here would go a half plus and then we go a quarter plus an eighth plus a 16th. And we see that a half plus a quarter is 0.75 plus 1 plus an eighth would be 7/8, which is 0.875. 15/16, we'd have to put into our calculator. But the next one after that would be 31/32. If we were adding these, and 1/64. The next one would be 63/64. And what we see is that this number becomes bigger and bigger. So we have like, so it could be say 99999 1 2 3 4 5 6 7 over a million. Sorry, over, so 9,900,000, yeah, 9,900,000 and blah, 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 over 10 million. And we see that this number is getting closer and closer to 1. And so we say that when we're going towards infinity, so as it's going towards infinity, the number tends to 1. And so this number says, well, if you went to infinity, what would it be? And it would be 7 plus all of these ones, which would tend to 1. So it would be 7 plus 1 is 8. So that's how we know that this answer here, 8, is correct. So that was just a bit of background. You don't really need to know all of this stuff here. It's just handy for your understanding. All you really need to know is this and how to substitute in this formula when they ask you for an infinite series. Okay, so that's geometric sequences to the sum of